Hello everyone, my name is Edgar Santiago. I'm a CCNA router and switching certified, and in this lab we're going to work with Dynamic Host Configuration Protocol. This protocol allows users to obtain IP address, netmask, gateway, and DNS server in an automatic way. That means that if we have 10, 100, 1000 hosts connected in our network, we don't need to put manually the information regarding with the networks to make a connection. We make a DHCP server and we allow that user obtain the information of IP address and all the stuff in an automatic way. The DHCP server is implemented with two UDP port numbers for its operation, which are the same as for the boot P protocol. UDP port number 67 is the destination port of the server, and UDP port number 68 is used by the client. In this lab, we have a router connected to the switch, and we got two hosts. I'm going to make the initial configuration on this router. First, I'm going to configure the IP address for that interface for the fast Ethernet 00. As you can see, we're going to work with a Class C IP address. So I'm going to assign manually the IP address 192.168.1.1, which is the first usable host on this network, to this interface. Interface fast Ethernet 00. After that, I'm going to assign IP address 68.1.1 with a 24-bit max, the 0. And we need to turn on that interface. After that, going to back to the global configuration mode. To make the DHCP server configuration, the command is IP DHCP pool. The pool is the name that we need to assign to regarding to that network, because we can have multiple DHCP pools when we are using VLANs to implement multiple broadcast. In this one, the pool is going to call LAN. After that, I need to assign what is the network of that pool. The network is 192.168.1.0 with 24-bit mask. After that, we need to assign the default gateway, which is the default router on the Cisco configuration, and this is the IP address for the fast Ethernet 00 interface. After that, we need to assign the lease. This lease is the amount of time that the host need to change that IP address and request another IP address from the DHCP server. If we put the question mark, we can use an infinite or we can use days. I'm going to use in this case 2 days. Also, you can use hours, and if I put 2 days 1 hour, and let's see how much I can far go, I can put minutes. So it's very specific in this way. I'm going to use only 2 days. The list is 2 days. Also, if I had a DNS server or if I don't have it, I can configure that DNS server so the clients receive this information in an automatic way. The DNS servers in this case I'm going to use is the public DNS server of Google, which is 8.8.8.8. After that, we have the configurations successfully created. But let's say that we want to exclude some address. As you can see, the only IP address taken for this network is the 192.168.1.1, which is for the fast Ethernet 00 on the R1. But if we need some IP address in a manually way, to manage like a switch, wireless LAN controller, printers, etc. It's good to put in practice to exclude some address. So the command is IP DHCP exclude address, and we're going to start from 192.168.1.1 through 192.168.1.10. So the DHCP server is going to deliver IP starting in 11. We got the configuration. I'm going to come to write this configuration from the running configuration to the startup configuration. Copy run startup config. We got three ways to do this. We can use the large command copy running configuration startup -config, or we can also use copy run start. Or also in some iOS, old iOS, you can use the WR as write, which is my favorite one. So I'm going to refer to the host A, and I'm going to request to that DHCP server the information, IP DHCP. As you can see, there are three Ds, and we need to wait. I'm going to use the command again, DORA, and that is the process that DHCP takes to deliver and communicate with the host. The D is for discovery, the O is for the offer, the R is for request, and the A is acknowledge. So first, the DHCP client broadcasts a DHCP discovery message looking for a DHCP server on port 67. The second, the DHCP server that received the DHCP discovery message send a layer 2 unicast this DHCP offer message back to the host. And the third one, which is the offer, the client then broadcasts to the server a DHCP request message asking for the offered IP address and possibly other information, unless the server finalizes the exchange with a unicast DHCP acknowledge message. I'm going to put a capture analyze on this interface using Wireshark, which is good to put in practice because this is our best friend in a real-world scenario to troubleshoot issues. And as you can see, we got this transmissions. I'm taking packets right now. Let's see. This is for the last lab. I don't know. Let me check. Okay, let's use the ENET0. Okay, we are right now. We are capturing packets for this. Actually, I'm using this for my whole connection, which is no good. This is the real thing going on my real LAN on my home. I'm going to close this and open again, starting capturing from here. Great. Right now we are only capturing packets for this interface only, not for my whole LAN, real LAN in my hardware appliance. So as you can see, we don't have any information regarding the discovery offer request and acknowledge for the DHCP, only CDP for the Cisco Discovery Protocol and some loop. I'm going to make a request to the DHCP server from host B, and the IP is DHCP on the command, in this case which is only for VPCs computers on GNS3. This command is IP DHCP. You're going to make the request. We are capturing the information right now. As you can see, we got the discovery, the offer, the request, and the acknowledge. So if we compare that with the information that I gave you, the first one is the discovery, and a discovery is a broadcast, and broadcast means in MAC addresses OF 255.255.255.255. And if we go to the network layer of that IP header, we got the version 4, the source is any, and the destination is any. So this is a broadcast packet. And if we go to the user data protocol, which is the transmission protocol that DHCP use, we see that the source port is 68 and the destination is 67. After that, I'm going to click on the DHCP offer, and the offer is a unicast, it's not a broadcast. And at this point, we got the source MAC address and destination. We got the source IP address, which is the gateway for the router, the facet in the 00 IP address, and the destination is the host, the 192.168.1.14, and as you can see, it's the same one as this one, and the same 67, 68 UDP. The offer, the request. The request is an broadcast. It's a broadcast, but we know at this point the source and destination MAC address using the inverse, because the 68 is the client and 67 is the server. And finally, the acknowledge. The server responds back with 67 to 68 from the IP server to the IP host. Now, to show you some verifying commands, so troubleshooting commands on the Cisco platform iOS. One of the commands that you need to know is show IP DHCP binding. With the binding command, we can verify which hosts are on our server, and we have the IP address of the particular host A, we got the MAC address, and the date that the list will expire. This, I don't have any configuration for the NTP, Network Time Protocol, or any of that, so we are on March 3 of 2002. And the other one is show IP DHCP pool LAN, which is the name of the pool. And with this command, we have the list address that we give, the total address, the utilization mark, and the current index. Right now, the list address, the last one. So this is all for now. In next video, we're going to work with DHCP for inter-VLAN configuration, and also we're going to make inter-VLAN for layer 3 switches and a router on a stick to make multiple VLANs crossed only for one link to the switch. Thank you for watching.